All right, guys, so we are going to begin the Unit 7 review. So make sure we read what it is I'm asking. The first one I'm saying is to convert from degrees to radians. So we need our two conversions that we need to have memorized are pi to 180 degrees or 180 degrees over pi. Since I'm given degrees and I want to go to radians, then I'm going to multiply by pi over 180 degrees. And then when I multiply straight across, my degrees will cancel, and then I'm left with just 140 pi over 180, which we need to reduce fractions. We can do that easily by typing in alpha y equals enter into our calculator and just typing in 140 over 180, and we should get 7 over 9. So our answer should be 7 pi over 9. Okay. This time we're going to go from degrees to radians. I don't care about the negative sign. I just want to convert. So here I want to cancel my degrees again. So I'm going to use that same conversion. Let me make that a little bit less thick. Let's see if that's better. Okay, yeah, that's better. Okay. So I'm going to convert this pi over 180. Once again, I want my degrees to cancel. So those would cancel here. Okay, I can't change. Okay, I got it. Okay, those are going to cancel, and then it's going to leave me with negative 135 pi over 180, which would reduce to negative 25 pi over 12. Okay, let's look at going the other way around. So here I'm going to be converting from radians to degrees. So my conversion factor I need to be using is if I want pi's to cancel, I need to be using, if I want pi's to cancel, I want pi to show up in the denominator. So I want to use this guy. So that's going to be 180 degrees over pi. My pi's are going to cancel. And then I can type this into my calculator. This times this divided by that. Either way, we should end up getting 585 degrees. So we can type in 13 over 4 times 180, and we should get 585. We're going to convert this to degrees, so I want pi in the denominator again. Same thing, these are going to cancel. I can type in negative 310 into my calculator times 180, and I should get negative 540 degrees. Coterminal means I want to have the same, they're going to have the same terminal side. So 473 degrees is outside of this range between 0 and 360. So from here, I need to subtract. This is where we add or subtract a full rotation. So here I would subtract to get one, and I should get 113 degrees. And radians, a full rotation is 2 pi. So find a positive and a negative coterminal angle. Okay, so this one is asking me to find a positive and negative coterminal angle. So if I'm finding a negative one, let's just see what that would be if I add. I'm going to make my denominator 7 here. So that would have to be, that says 2 pi, right? 14 divided by 7 is 2. So that says 2 pi. If I were to add those together, I get negative 2 pi over 7. So that's still, I added it, and that's still negative. So I'm going to say that's one of them. And then I'm going to add another 14 pi over 7 to that one as well. And that's going to give me 12 pi over 7. All right, let's find a coterminal angle between 360 degrees and 720 degrees. Once again, that just means I'm going to be adding 360 degrees until I get somewhere in that range. I'm going to have to do this more than once. So I'm going to have to, if I do that, negative 105 plus 360 degrees gives me 255 degrees, which is not quite in there, so I'm going to have to do this one more time and add that twice, and then I get 615 degrees. That falls between these guys. All right, what quadrant does the terminal side lie? So I'm going to find out. In order to do this, I'm going to kind of make a rough sketch, and I always want, if I'm looking for a terminal side, I want that to be between 0 and 360. So I'm going to subtract 360 degrees from this, and that's going to give me 225 degrees. And now if I know that that's 0, this is 90, that's 180, this is 270, and then all the way back around is 360, that I know 225 degrees is going to be somewhere in this third quadrant, so quadrant 3. What side does this terminal side lie? So I'm going to go back through and I'm going to label these, and I'm going to label my I'm going to label this with respect to the denominator of 10. So this is going to say 5 pi over 10 for the 1/2. Oops. This is going to say 10 pi over 10. This is 20 pi over 10. So this one's going to be 15 pi over 10. And where does 7 fall? 7 is in between 5 and 10, so that's going to be right here in quadrant 2. The other way I can do this is I can say, okay, I'm going to break this into 10 evenly spaced little things. So 1, 2, 3. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So going 7 around, this would be right there. That's another way I can do that. If I'm just asked to sketch the angle and standard position, I like to get everything between 0 and 2 pi or 0 and 360 degrees. So I'm going to start by finding a coterminal angle by adding 360 degrees inside of here. And that's because I've already labeled and are familiar with these, right? So that's we going back around, and this makes it a little more simpler so we don't have to think about the negatives. Because all we're trying to do is figure out where it exists. So this comes out to 168 degrees, which 168 degrees is between 180 and 90 degrees, but closer to 180. So somewhere about right here. And then, so this would be 168 degrees. And then to find the reference angle, that's talking about that angle. So how far away are we between 180 and 68? So 68, 78, 79, 80. So 12 degrees. Is my reference angle. Reference angle is how far away are we from the x-axis. Okay, so we can do this a couple ways. One of the ways I can do this is I can break this apart into 4 different spots, so between 0 and pi, I can say, okay, there's 1, 2, 3, 4, and that's coming from this. And so we're looking at these right here. So I would go 1, 2, 3, but I'm going past that. So 4, 5, 6, 7. And then we would have 8, 9, 10, 11, 12, 13, 14, 15. So I'm looking right there in that little 16th area, or 15th area, sorry. So I know I've gone around at least one time all the way around. Another way we can think about this is I'm going to find a coterminal angle and that is closer to between 0 and 2 pi. So I'm going to go and I'm going to do 15 pi over 4, and I'm going to subtract 2 pi. So 2 pi would be 8 pi over 4 in this case, because I want my denominators to be the same. And then I end up getting 7 pi over 4. And if you remember, if this is 0, this is, what is that? Okay, so this would need to be 2 pi. This would need to be 4 pi. And this would need to be halfway between 0 and 8 pi. So 6 pi. Where does 7 pi over 4 fall? It's in between 6 and 8 is where 7 falls. So this would be in quadrant 4. And so if this is 7 pi over 4, how far away, what's the distance between these two? Well, 8 pi over 4 minus 7 pi over 4 is just pi over 4. The shortcut is, in most cases, we can just cover up that coefficient in front of the pi. So our reference angle is just pi over 4. Remember that reference angle is always going to be between 0 and pi over 2 with radians, and 0 and 90 degrees with degrees. All right, draw the angle 245 degrees in standard position. So that's 0, that's 90, 180, 270, back all the way around to 360 degrees. 245 degrees would be somewhere in quadrant 3. How far away from the x-axis am I? So the difference between 245 and 180 is what I'm looking at. That will give me this distance right here, or that angle right there. And then that should come out to 65 degrees. All right, and that is, I believe that's your review. Let's see if there's anything else. No, that's it. Okay. Well, good luck.